Hello, everyone. Welcome to First Online University, a global platform for all your education and growth related needs. In this lecture, we are going to continue with the chapter P block elements, and we are now going to start with group 14 elements because we've already covered till group 13 along with the previous year questions. And in this particular lecture, we are going to be discussing the physical properties of group 14 elements, all the elements of group 14. Before we begin, a piece of information for you. You can use the coupon codes Mission J or Mission NEET while you enroll at First Online University for Mission J or NEET in order to avail good discounts. Let's begin with the introduction and properties of Group 4A or Group 14 elements. Now, when we talk about Group 14 elements, it includes carbon, silicon, germanium, tin, and lead. Okay, these are the 5 elements carbon, silicon, germanium, tin, and lead, which belong to group 14 of the periodic table. Now, what are the properties? We are now going to be discussing the physical properties. The first one is electronic configuration. Now, if you look at the electronic configuration of, say, carbon, which has atomic number equal to 6, it would be 1s2, 2s2, 2p2. Right? Therefore, all the elements of group 14 are going to have the same electronic configuration, that is ns2, np2. Okay, so the general electronic configuration is ns2np2. When I talk about carbon 6, it is 1s2, 2s2. This 2 is actually in the superscript 2p2. Okay, so 2s2, 2p2 is the valence shell electronic configuration. For silicon, which has atomic number 14, it would be 1s2, 2s2, 2p6, 3s2, 3p2. For germanium, which has the atomic number equal to 32, the electronic configuration would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p2. Okay, so it has d10 also in the valence shell configuration, but we consider only 4s2, 4p2. Then we have tin with atomic number 50 would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p2. And lastly, we have lead, which has the electronic configuration, atomic number 82, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, and 5d10 and 6p2. Okay, so in the end, what we have is 6s2, 6p2. That is the general, that is the valence shell electronic configuration. So if we want to now, so we've talked about electronic configuration. You do not have to learn the entire configurations, as I've told you for group 13 also. Just the previous noble gas and the rest of the configuration. That would just solve your purpose. Next, we talk about the abundance. Now, abundance of these elements in the Earth's crust is in the order silicon is the most abundant, followed by carbon, then tin, then lead, and lastly germanium. When we talk about its occurrence, carbon exists in the elemental state and also in the combined form. Silicon exists as silica and silicates. Tin exists as cassiterite or tin stone, that is SnO2. Lead exists as galena, that is lead sulfide, or cerussite, that is lead carbonate. The next physical property is atomic or ionic radius. That's the same thing. If we talk about the ionic radius increasing down the group, the atomic radius will also increase down the group. So down the group, atomic size increases with the increase in atomic number because the electrons are being added in new shells. Okay. So if we look at the atomic radius, it goes on increasing down the group without any exception. Okay, you can look at the sizes going on to increasing. Okay, next is ionization enthalpy. So down the group, as the size is going to increase, it becomes easier for the effective nuclear charge decreases. So it becomes easier for the valence shell electrons to get removed easily, and therefore we say that ionization enthalpy is going to be decreasing down the group. So ionization enthalpy decreases with increase in atomic radii because electrons become more loosely held due to shielding by the inner electrons of the inner shells. Okay, so if this is the atom and the electron that is present, when one electron is going to be removed, it is going to be the first ionization enthalpy or IE1. That will give the atom a positive charge, and now that forms a monovalent cation. Now, when a second electron has to be removed, i.e. 2 is going to be considered, and we will have two positive charges on this particular ion, which is a divalent cation now. So what are, if we talk about the elements of group 14 and the ionization enthalpy values in kilojoules per mole, we see that there is a significant decrease from carbon to tin, but marginally it increases for lead. Okay, and carbon has the highest ionization enthalpy, therefore the order would be carbon, silicon, germanium, lead, and then tin. Okay, marginal increase. Okay, the values are not given. I think the table is missing here, but not so important. The order is what is important. Okay, next is electronegativity. Now, electronegativity decreases from carbon to silicon. So, from carbon, as we go to the next element, that is silicon, the electronegativity decreases. But from silicon to tin, it remains almost constant. And then for lead, it increases marginally. Okay. So, carbon 2.5, silicon 1.8. So, there is a decrease. Then for germanium, again 1.8, tin 1.8 remains constant. And for lead, it marginally increases to 1.9. So therefore, carbon is the most electronegative element of group 14 of the periodic table. Next physical property. So in general, if you look at the appearance, etc. of these, then all the group 14 elements are solids. Okay. Carbon and silicon. Now this is a very important part here. Carbon and silicon are non-metals. Germanium and tin are metalloids, and lead is a soft metal. Okay. Then down the group, there is a regular decrease in melting and boiling points, but the densities are going to increase because density is mass upon volume. Now, although the size is increasing, the volume is increasing, but the mass is increasing more proportionately. Therefore, we can say that down the group, since the mass is going to increase, therefore densities are going to increase, and melting and boiling points are going to decrease in a regular manner because the size increases and now it becomes easier to melt the crystal lattice. And similar is the case for boiling. So for melting point, carbon, silicon, germanium, lead and tin. Okay, for marginally, lead is going to have a higher melting or boiling point as compared to tin, marginally. Then boiling point is going to follow this order where first is carbon, then germanium, then tin, then silicon, and lastly lead. So you will have to remember these. There is no one particular order which is going to be followed for both melting point as well as boiling point. So you have to remember these trends, okay? You have to remember the exceptions. So this order is very, very, very important. So, and the density order would be from carbon to silicon to germanium to tin and then lead. It's going to first from carbon to silicon it will decrease and then it is going to increase. Okay, this is also something that you have to remember. So lead will have the highest, followed by tin, then germanium, then carbon, and lastly silicon. So all these three trends or orders that we have discussed for melting point, for boiling point, and for density for group 14 elements is very, very important. You will have to learn them. Okay. Then group 14 elements have higher melting and boiling points than group 13 elements because as we go from left to right in a period, the size is going to decrease, effective nuclear charge increases, and therefore compactness is going to increase. Now let's do a few MCQs based on what we have learned. Well-known radioactive isotope of carbon is carbon 12, carbon 13, 14 or 11. See, carbon 12 is the normal carbon that we have. Carbon 13 is the radioactive carbon 14 is the radioactive isotope, which is well known. Okay, so option C is the correct answer. Next is which of the following group 14 elements shows highest density? We have discussed the density order and we have seen that from carbon to silicon density decreases, but then it goes on increasing, and therefore the last element, which is lead, has the highest density. Option D is the correct answer. Next question is the number of valence shell electrons in carbon atom is. So we have seen it is 2s2, 2p2. So there are 4 valence shell electrons. See, why are we considering S also and not only P? Because we are talking about the shell. We are not talking about valence subshell. We are talking about valence shell, and shell means n is equal to 2. So for n is equal to 2, we have 2 electrons in the s subshell and 2 electrons in the p subshell. Therefore, overall the valence shell electrons is going to be 4. 2 plus 2, 4. Next question is, which of the following elements is a soft metal with lower melting point? So we have seen that carbon, silicon, germanium, these are not metals. It is only lead that's a metal and also a soft metal. So option D is the correct answer. Next question is if electronegativity of silicon is 1.8, then electronegativity of germanium is. So we have seen that it is going to be the same. It's going to remain constant. There is a marginal, it's going to remain constant. So option C is the correct answer. That is 1.8 for silicon, therefore 1.8 for germanium. So this is all about the physical properties of group 14 elements that we had to discuss. I know there are a few things that have no logics behind because they've been experimentally derived or proved, and therefore you will have to learn those trends or orders. We cannot do anything in that. You will have to be, that's like you will get memory based questions on them. So you will have to memorize them. You can subscribe to our YouTube channel for joining YouTube live classes for best NEET or JEE coaching. You can also download the First Online University mobile app through Google Play Store or App Store for continuous learning through your smartphones. Keep learning with First Online University, a team of millions of learners and educators worldwide.